Hello students, today we are going to discuss important problem in wave optics. In Young's experiment, monochromatic light is used to illuminate the two slits A and B. Interference fringes are observed on a screen placed in front of the slits. Now if a thin glass plate is placed normally in the path of the beam coming from the slit, then what will happen? Dear student, whenever we place any transparent slab in front of any one slit, then fringe width do not get changed. Only what happens? Complete fringe pattern gets shift towards that slit in front of which the slab is introduced. Okay, so the answer to this question is fringe width will not change. There will not be any change in the fringe width. So out of 4 choice, the correct answer is option 4. In this case, the diagram, if initial diagram was like this, then this fringe pattern will shift in this direction. Okay. In Young's double slit experiment, if width of the slits are in the ratio 4:9, then ratio of intensity of maxima to intensity of minima will be. Dear student, in the question, width of the slit are given in the ratio. Okay. Intensity is directly proportional to slit width. W1 upon W2 is given 4/9. Means this is equal to I1 upon I2. So A1 upon A2 will be equal to 2/3. A1 upon A2 plus 1 whole square. A1 upon A2 minus 1 whole square. This is ratio of maximum and minimum intensity. So answer to the given question is 2/3 plus 1 whole square divided by 2/3 minus 1 whole square. After solving this will be 2 plus 3, 5 means 25 upon 1. So out of 4 choice, the correct choice is option 3. Option 3 is the correct choice. In an interference experiment, the spacing between successive maxima or minima. This is the definition of the fringe width. Distance between any two consecutive bright fringe or any two consecutive dark fringe is called fringe width. Okay. This is equal to d lambda upon d, denoted by letter B. This is d lambda upon d. This is the fringe width. So out of 4 choice, the correct answer is option 2. In Young's double slit experiment, a mica sheet of thickness T and refractive index mu is introduced in the path of ray from the first source S1. By how much distance the fringe pattern will be displaced? This is the question. Now we are introducing a slab of thickness T and refractive index mu in front of slit S1. So what will happen? This complete fringe pattern will shift in this direction into T. If shift is equal to X, this is equal to XD upon D. And what is D? Small d is the separation between coherent sources. Small d is the separation between coherent sources, and capital D is what? Capital D is the distance of the screen from the plane of the slits. Okay. So after solving this, we will get mu minus 1 into T into D upon D. This is the solution. So out of 4 choice, the correct answer is option 2. In Young's double slit experiment using sodium light lambda equal to 5898 angstrom, 92 fringes are seen. If given color lambda equal to 5461 angstrom is used, how many fringes will be seen? Dear student, in a certain distance x, since fringe width equal to d lambda upon d, if lambda is decreased, then what will happen? Fringe width will decrease. If fringe width will decrease, then definitely in a certain distance number of fringe will increase. So directly we can use the formula n1 beta 1 equal to n2 beta 2. Okay. So n1 92 into 5898 equal to n2 into 5461. If we solve this equation, 92 into 5898 divided by 5461, then definitely this is coming. This will definitely more than 92. So this is 99. Out of 4 choice, the correct answer is option 4 is the correct answer. In double slit experiment, the angular width of the fringes is 0.2 degree. For sodium light, lambda equal to 5890 angstrom. In order to increase the angular width of the fringes by 10%, the necessary change in the wavelength is. Dear student, this is linear fringe width beta equal to d lambda upon d, and this is angular fringe width lambda theta equal to beta upon d. Beta upon d means lambda upon d. This is angular fringe width. Now, to increase the angular fringe width by 10%, theta is directly proportional to lambda. So delta theta upon theta into percent 100 equal to delta lambda upon lambda into 100. Definitely lambda is to be increased by 10%. Okay, 5890 angstrom. Its 10% value is how much? 589 angstrom. Okay, so answer to the given question is option 1. Fringe width is to be increased by 5899 angstrom. 589 angstrom to increase the angular fringe width by 10%. So correct choice is option 1. Two waves are represented by the equations y1 equal to a sin omega t and y2 equal to a cos omega t. The first wave, the phase relation between cos theta and sin theta is pi by 2. Okay, y2 can be written as a sin omega t plus pi by 2. So phase difference. So first wave is leading. First wave is y1 equal to a sin omega t. The second wave is leading by a phase of pi by 2. First wave lags the seconds by pi by 2. Okay, out of 4 choice, the correct choice is option 4. Correct choice is option 4. The resultant amplitude of a vibrating particle by the superposition of two waves y1 equal to a sin omega t plus pi by 3 and y2 equal to a sin omega t. Dear student, in the two waves phase difference is pi by 3. Now formula for resultant amplitude is a1 square plus a2 square plus 2 a1 a2 cos phi under root. So amplitude of both the waves is same. So from vector you can directly use the relation. This is 60 degree a root 3, or you can solve like this: a square plus 2a square cos 60 means 1 by 2. So this is 3a square means a root 3. This is the answer. Out of 4 choice, the correct choice is option 4. Two coherent sources of different intensities send waves which interfere. The ratio of maximum and minimum intensity in the interface pattern is 25. Then find ratio of intensity of source. See in the question what is given? Ratio of maximum and minimum is given. I maximum upon I minimum is given 25. Means what? A1 plus A2 whole square upon A1 minus A2 whole square. This is equal to 25. So we get A1 plus A2 upon A1 minus A2. This is equal to 5. So after solving this, we get A1 plus A2 equal to 5A1 minus 5A2. So we get 4A1 equal to 6A2. We get A1 upon A2 equal to 3 upon 2. So what is I1 upon I2? Finally, I1 upon I2 equal to 9 upon 4. So out of 4 choice, the correct choice is option 3. Option 3 is the correct choice. Two coherent sources of intensities I1 and I2 produce an interference pattern. The maximum intensity in the interference pattern will be, maximum is what? I1 plus I2 plus 2 under root I1 I2. This is maximum. When phase difference remains 0. So this can be written as under root I1 plus under root I2 whole square. So out of 4 choice, the correct choice is option 4. Option 4 is the correct answer. In an interference pattern have maximum and minimum intensities in 36:1, then what will be the ratio of amplitude? Dear student, in the question, ratio of maximum and minimum intensity is given 36:1. I maximum upon I minimum is given 36 upon 1. That is equal to A1 plus A2 whole square upon A1 minus A2 whole square if amplitude of superposing waves are A1 and A2 respectively. Taking square root, we get A1 plus A2 upon A1 minus A2. This is equal to 6 upon 1. Make cross multiplication, A1 plus A2 equal to 6A1 minus 6A2. After solving this, we get 5A1 equal to 7A2. So A1 upon A2 equal to 7 upon 5. So the correct answer is option 4. When a thin transparent plate of thickness T and refractive index mu is placed in the path of the two interfering waves of light, then part difference will change by. Part difference, this is direct formula, part difference will change by mu minus 1 into T. So correct choice is option 2. Two waves y1 equal to a sin omega t and y2 equal to a sin omega t plus delta are producing interference, then resultant intensity is. Dear student, phase difference between them is delta. So resultant intensity will be, first write the resultant amplitude. Resultant amplitude will be a square plus 2a square cos delta. This is 2a square, 1 plus cos delta. And what is cos delta? Cos delta is 2 cos square delta by 2 minus 1. And this is what? 4a square cos square delta by 2. And this is 2a cos delta by 2. This is result. I is what? I is equal to r square. So this is 4a square cos square delta by 2. So out of 4 choice, the correct choice is option 4 is the correct choice. Due to effect of interference, floating oil layer in water is visible colored. Due to observation of this event, the thickness of layer should be minimum thickness should be 10,000 angstrom, means 1000 nanometer. Out of 4 choice, the correct answer is option 2. In YDAC experiment, when two light waves makes third minima, then they have for third minima, destructive interference should take place, and for minima, this is the part difference. For third minima, n equal to 3. So this is 5 lambda by 2 part difference. So part difference of 5 lambda by 2. Option 4 is the correct answer. Out of 4 choice, the correct choice is option 4. Or if you want to write phase difference, this is 2n minus 1 pi. So for third minima, this should be 5 pi. Okay. If I1 upon I2 equal to 9 upon 1, then I maximum upon I minimum. Dear student, I1 upon I2 is given 9 upon 1, means A1 upon A2 will be 3 upon 1. So I maximum upon I minimum equal to what? A1 upon A2 plus 1 whole square divided by A1 upon A2 minus 1 whole square. This is 16 divided, this is 4, this is 4. So out of 4 choice, the correct choice is 4:1. So option 3 is the correct answer. Hello student, this is a very good question in wave optics. In Young's double slit experiment, one of the slit is wider, means its intensity is more than other, wider than other, so that the amplitude of the light from one slit is double of that of the other slit. If IM is the maximum intensity, the resultant intensity when they will interfere at phase difference phi is given by. Dear student, in the question, it is given A2 equal to 2A1. This is given. If A1 equal to A node, then we can write A1 equal to A node, and then we can write I1 equal to I node and I2 equal to 4A1 square, means 4I node. Okay. And what is I maximum? I maximum equal to I1 plus I2 plus 2 under root I1 I2. So this is 5I node plus 4I node. This is 9I node. This is I maximum. Okay. So I node equal to I maximum upon 9. Now let's find the solution of this question. In this question, phase difference is given 5. Resultant intensity will be equal to I node plus I1 plus I2 plus 2 under root I1 I2 cos phi. Okay, after solving this, we will get 5I node plus 2 into 2, 4 I node cos phi. This is the solution, means I node 5 plus 4 cos phi. So now in place of cos phi, we will write 2 cos square 5 by 2 minus 1. So we will get I node 5 plus 4, 2 cos square 5 by 2 minus 1. So this is 8 and this is minus 4. So this is I node 1 plus 8 cos square 5 by 2. Okay. And what is I node? I node is I maximum upon 9. So answer to the given question is I maximum, that is Im upon 9 in bracket 1 plus 8 cos square 5 by 2. Out of 4 choice, the correct choice is option 3. Option 3 is the correct choice for the question. So we will tick option 3 is correct answer. Okay. In Young's double slit experiment, when wavelength of 700 nanometer is used, then fringe width of 0.7 nanometer is obtained. If wavelength of 500 nanometer is used, then what is fringe width? Dear student, in YDSC experiment, beta is written as d lambda upon d. Beta is directly proportional to lambda. Okay. So beta 2 upon beta 1 equal to lambda 2 upon lambda 1. So we will get beta 2 upon beta 1 is 0.7 equal to lambda 2 beta 2 upon beta 1 equal to lambda 2, that is 500 upon lambda 1, this is 700. So after solving this, we will get 0, 0 will get cancelled. So beta 2 will be equal to how much? 5 upon 7 into 0.7. So this is 0.5. 0.5 means what? 0.5 nanometer. Okay. Same 0.5, no, not nanometer. This is 0.5 millimeter. Okay. Units are very important. So out of 4 choice, the correct answer is option 2. Option 2 is the correct answer. Monochromatic green light has wavelength 5 into 10 power minus 7 meter. The separation between slits is 1 millimeter. The fringe width of interference pattern obtained on screen at a distance of 2 meters. Dear student, lambda is given 5 into 10 power minus 7 and formula for fringe width is d lambda upon d. D is 2. Lambda is 5 into 10 power minus 7 and small d is 1 millimeter. This is 10, this is 10 power minus 4 meter. So this is 10 power minus 3 meter. So this is 1 millimeter. So out of 4 choice, the correct answer is option 1. Option 1 is the correct answer. Okay, 1 millimeter. In Young experiment, ratio of maximum and minimum intensity is 9:1. In fringe system, then ratio of amplitude of coherent sources. Direct formula A1 plus A2 whole square divided by A1 minus A2 whole square equal to 9 upon 1. So this is A1 plus A2 upon A1 minus A2. This is equal to 3. On cross multiplication, we get A1 plus A2 equal to 3A1 minus 3A2. So this is 2A1 equal to 4A2. So A1 upon A2 equal to 2:1. So out of 4 choice, the correct answer is option 3. Option 3 is the correct answer. Okay.